In this lesson, we are going to be looking at the standard normal probability distribution. There are many different types of normal curves. Each random variable that is measured has a different normal curve since every variable will have its own mean and own standard deviation. So the goal of a standard normal probability distribution is to be able to standardize various normal distributions that all have different means and different standard deviations. So let's take a look at a concrete example. Abbott takes a maths SL test and scores 91%. The scores are normally distributed with a mean of 86 and a standard deviation of 4. Costello takes an English SL test and scores 89%. The scores for his class are normally distributed with a mean of 83 and a standard deviation of 5. Who had a stronger performance? Now, all of us knows that different classes have varying levels of difficulty. Some might argue that a math test is harder than an English test or vice versa. So who actually had the stronger performance? Is it Abbott because he has a higher raw score? Or is it Costello because maybe his class is more challenging? I mean, the mean of his class is only 83 compared to the mean in the SL class, which is 86. So what we can do here is look at something called a Z-score. What we want to know is how many standard deviations from the mean did Abbott and Costello score. So Abbott's test was 91. We are going to scale it back and see how far it was from the mean. So we are taking 91 and subtracting away 86. The standard deviation is 4, so we're going to divide by 4. So how much higher is Abbott's score compared to the mean? He is 1.25 standard deviations above the mean. Now let's do the same thing with Costello's score. We'll take his score and we'll see how far it is away from the mean. So 89 minus 83, and then we're going to divide by the standard deviation, which is 5. So it turns out that Costello is 1 standard deviation away from the mean, above the mean in this case. So it looks like, based on both the raw score and the overall standardized performance, Abbott had the stronger performance. And therein lies the utility of Z-scores. So this leads us to the Z distribution, which is the standard normal distribution. The formula to calculate a Z-score is shown on the screen. So we take the observation value represented by X, we subtract the mean represented by mu, and we divide by the standard deviation represented by lowercase sigma. So what exactly is the Z distribution? We're thinking in terms of how many standard deviations away from a mean something is. So the first step to calculating a Z-score is really we're scaling. We're performing a horizontal translation. We want to make a standard mean of 0. That is why we subtract the mean. So we're transforming our normal distribution to a standard normal distribution, which has a mean of 0. And then we are going to change the X units in order to represent standard deviation of 1. So we are going to divide that difference by the standard deviation to get our standard normal curve. Again, here's an illustration of the empirical rule using the Z distribution or the standard normal distribution. So if we are 1 standard deviation away from the mean, which is 0, then we have a probability of 68% of that occurring. There's a 95% of observations that fall within 2 standard deviations from the mean, and there's a 99.7% likelihood that something falls within 3 standard deviations of the mean. So that's it for this mini lesson. In the next video, we are going to look at how to use the Z distribution or the Z-score to find an unknown mean and unknown standard deviation. See you in the next video.